Here we're talking about a radical expression, the bth root of a. The radical symbol is the line that separates the b and the a. That's this. That's the radical symbol. B is called the index and a is called the radicand. What is it? It is a number. And what number is it? It's a number whose bth power is a. In the case where b is even, you want to take the non-negative choice. The bth root of a, and then you take the bth power, you get a. So here's an example. The square root of 25, which is the same as when you have a 2 in the index position, is 5. So the square root of 25 is 5. Since 5 squared is 25 and 5 is greater than or equal to 0. Another example. The cubed root of negative 27 is equal to negative 3, since negative 3 to the third power is negative 27. Now we're going to talk about rational exponents and also simplifying radicals. Just like we had to define the 0 exponent and the negative exponents, negative integer exponents, we need to also find out what happens when you have a rational exponent. So we want to know what 2 to the 1/3 means. But we want to actually define it in order that the regular rules of exponents work. So in particular, if we take the cube of that, we should multiply the exponents, but 1/3 times 3 is just 1, so we should get 2. So whatever 2 to the 1/3 is, it satisfies the equation x cubed equals 2. So 2 to the 1/3 must equal cube root of 2, since cube root of 2 is exactly the number whose cube is 2, which is what that equation says. Similarly, 3 to the 1/2 squared is equal to 3 to the 1/2 times 2, which is 3 to the 1, or 3. So 3 to the 1/2 satisfies the equation x squared equals 3. Assuming 3 to the 1/2 is greater than or equal to 0, we see that 3 to the 1/2 is the square root of 3. Since square root of 3 is the positive number whose square is 3. In general, we should, if the laws of exponents are to hold, define a to the 1/b to be the bth root of a. That is, the number, or in the case of even b, the positive number whose bth power is a. So this is going to be true for b equal to 2, 3, 4, and so on. Okay, let's look at these examples. What is the cube root of 27x cubed? I'm going to first interpret this as a power because we have rules of exponents. And now we distribute. That's 27 to the 1/3 times x to the 3 times 1/3. That's equal to 3 times x, because 3 times 1/3 is 1. X to the 9 to the 1/2. There are a number of ways I guess you could do this, but this is x to the 9 over 2 then, which is equal to x to the 4 plus 1/2. This I'm writing as a mixed number, And now I'm going to use the properties of the exponent. This is x to the fourth times x to the 1/2, which is x to the fourth square root of x. Let's do this example. This is equal to 3x squared y to the 1/2, 15x to the 7th y to the 1/2, which is equal to, let's use 3a, put these all under one exponent. They're kind of undistributing, and then we can simplify this. This is 3 squared times 5, so 15 is 5 times 3. Then we have x to the 9th, which is x to the 8th times x. We have y squared. So I want an even power times x, or I want an even power times nothing if possible. So that's what we've done there. And now 3 squared to the 1/2 is 3. So this to the 1/2 is 3. We cannot do anything with the 5. X to the 8th to the 1/2 is x to the 4th. X to the 1/2 is just x to the 1/2. Y squared to the 1/2 is y. So, putting this together, we get that this is 9 x to the 4th y, and then writing it in terms of a square root, because that's what the original problem was written in terms of, we get this. So we discover here the familiar properties of roots, that the square root of a times the square root of b is the square root of ab. That follows from 3a. Square root of a over square root of b is equal to the square root of a over b. That follows from 3b. Let's look at some examples with numbers. The square root of 150 is equal to the square root. I'm going to factor 150 so that I can see what can be written as a square. So 5 squared square root is just 5. And there's nothing we can do with the 2 times 3, which is equal to 5 square root of 6. This is just 5 cubed. Which is equal to, I'm going to write this as 5 squared times 5. We peel off one of the 5's. 5 squared square root is 5. The other 5 is left under the radical. So I'm going to indicate which of these 5's this is. 40 is 2 cubed times 5, which is 2 squared times 2 times 5, which is 2 square root of 10. Okay, you try to simplify these three. They're very similar to what was done above. The answers are at the bottom of the PDF file. And they're right there also.